Now let us consider the function y of k, which is the sum of functions x of h, where h is from 0 to k, such that y of k is equal to sigma h is 0 to k x of h, and k is varying from 0 to infinity, where y of k is equal to 0 for all k less than 0. Obtain the z transform of y of k. So our question here is to obtain the z transform of y of k. Z transform of y of k, which is nothing but y of z. This is what we will have to find from this equation. Okay, so looking at this equation, we will have to find out and use the theorem or the shifting theorem here. For example, let us say y of k. Consider this function y of k. What is y of k? If you can elaborate it, what you see, it is ranging from h is from 0 to k. Therefore, x of 0 plus x of 1 plus x of 2 plus so on plus x of k minus 1 plus x of k. That is, this is the sum. Y of k is the sum of many functions. It is the sum of functions x of h, that is x of 0, x of 1, x of 2, x of k minus 1 and x of k. For example, if we can consider y of k minus 1, let us say, and h is ranging from 0 to k. When k is k minus 1, h will be ranging from 0 to k minus 1. Therefore, I have x of 0 plus x of 1 plus x of 2 plus so on plus x of k minus 1. Here y of k minus 1, you are having the values of h from 0 to k minus 1. Now I have these two equations at my behest. Now if I subtract 2 from 1, equation 1 minus 2 gives me y of k minus y of k minus 1 is equal to, you can cancel out all these equations and you will be left over with x of k. Therefore, I am left over with one equation, that is y of k minus y of k minus y of k minus 1 is equal to x of k. Now when I apply z transforms to these functions, to this function equation 3 to equation 3, I will have y of z minus z inverse. This is the time delayed real translation theorem. Z inverse y of z which is equal to x of z. Now if I have, the question here for us is what is y of z. Now y of z, if I consider it as common in these two cases, I will have y of z into 1 minus z inverse, which is equal to x of z. Therefore y of z is equal to 1 by 1 minus z inverse into x of z. So this is how we will be using this real translation theorem to get the result y of z when you are having y of k is the sum of many functions x of h. So with this in mind, we will go into the next theorem. Next theorem, that is the initial value theorem. Initial value theorem. Initial value theorem is nothing but finding out the value of the at the initial point x of 0. X of 0, it is nothing but limit as z tends to infinity x of z. Limit as z tends to infinity x of z. This is called the initial value theorem. This is for all x of k is equal to 0 for all k less than 0, and this is a function, and x of k exists for all k greater than or equal to 0. Now let us say what is x of z for us. By definition, sigma k is from 0 to infinity x of k z power minus k. Now when I elaborate this, I will have x of 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus so on up to infinity, I will have x of z. Now when I consider the limit functions z tends to infinity throughout, therefore I will have this as limit z tends to infinity. Now what is this function limit z tends to infinity? You will have when z tends to infinity 1 by z gives you 0. This is going to 0, this is going to 0, and the rest remaining all the terms up to infinity are going to 0. Therefore I am left over with only x of 0. Therefore x of 0 is equal to limit z tends to infinity x of z. This is called the initial value theorem of the z transform. In a similar way, we will try and find out what is the final value theorem of the z transform. So the final value theorem states that limit as k tends to infinity x of k is equal to limit as z tends to 1 minus z inverse x of z. Now to prove this theorem, we will consider the z transform of x of k. By definition we have sigma k is from 0 to infinity x of k z power minus k. Now similarly we will consider z of x of k minus 1, which is sigma, which is nothing but, this is called x of z. Now for this, as for the real translation theorem, you can say it is z inverse of x of z, or this is nothing but sigma k is from 1 to infinity x of k z power minus k. Now when I subtract equation 1 with equation 2, we get sigma k is from 0 to infinity x of k z power minus k minus sigma k is from 1 to infinity x of k z power minus k, which is given by x of z minus z inverse x of z. Now when we subtract these two, for when we apply limits from z, limit as z tends to 1 to this entire equation, and limit as z tends to 1 for this entire equation, we are left over with, when z tends to 1, now what is the function here? K is from 0 to infinity x of k z power minus k minus sigma k is from 1 to infinity z power minus k. If I substitute is 1, you will getting it 1, then x of k, which is nothing but limit as z tends to 1 minus z inverse x of z, 1 minus z inverse x of k. Now with this equation you will get x of k as limit k tends to infinity, you get limit z tends to 1 minus z inverse x of z. So the proof for this final value theorem is obtained as such.